So this is the picture of the lug support. So we started the design of the vessel supports, and we started with the skirt support. Now the lug support is also used for the tall vertical column, and you see here these are the bracket support, and it is always installed by a multiple of 4. So it is here 90 degree, 90 degree, and the opposite of that 90 degree. So it should be always a multiple of 4 number. And it is used for the thick pressure vessel also. What is that actually? This is the bracket. Okay. It is the angle we generally use for holding a rack mounted on a wall. And you see this is known as a gusset plate. It creates extra support, or it strengthens the joint. So this is the purpose of using this. So this is nothing but a gusset plate. So similarly here, a metallic pad, okay, of mild steel is reinforced, is attached with the pressure vessel. This is the pad, and on the pad the lug support is attached, where a vertical plate is there, so horizontal plate is there, and two gusset plate is attached with it. It may be the two horizontal plate with two vertical gusset, and you see in the next figure, and these are the legs, and it is attached at the bottom with the foundations by means of the bolt. Now you see, suppose there is a wind force, wind is flowing from one side, so the main stresses on the lug support is of two types. One is the compressive due to its weight when the vessel is full of fluid. So the weight for that will create a compressive force. And due to the wind force, there may be the compressive or expanding. Okay, suppose this is the wind side, so up to the axis. Okay, okay. So from the wind side to the up to the axis of the pressure vessel, the support will experience the expansive force, and opposite to the axis, this direction will experience a compressive force. So The design of the lag support is based on the compressive force, because in this side there is a weight, that is compressive force in this lag, but the opposing force, that is the expanding force. So the total net force is little bit less value than that of the total axial stress or axial or compressive force in this leeward side. So leeward side. So the lag support is always be designed based on the compressive load. Now we write this design of lug or bracket support. So it is generally used, you please write, generally used for thick vessel having height to diameter ratio between 2 and 3, and this type of support capable of absorbing the bending stresses due to eccentricity of load. Eccentricity of loads. Okay. Then can be easily constructed and attached to the vessel wall with a minimum length of weld seam. With a minimum weld seam length. And they are made to rest on short column. Comparatively low cost construction Now, if the diameter of the vessel versus the number of bracket, so the rules is if the diameter is up to 0.8 meter diameter, okay, to 3 meter, it is 4. Up to 5 meter, it is 6. No, that is not of a multiple of 4 but multiple of 2. Okay, and above 5 meter, it is 8. Now, for thin wall vessel, for thin walled vessel, either reinforcement is done at where bracket is attached to the cell, or you have to use many brackets. Sometimes a pad is used, a metallic pad is used, then the bracket is then welded to the pad. The thickness of the pad is minimum 6 mm thickness. You see here, this is the pad. Okay, so your pad is there. Okay, it is welded with the shell, and on the pad, the lug support or the bracket is attached. Now, the main load, I already told, on the bracket, the main load on the bracket support or the dead weight or the dead weight of the vessel and the wind and the wind load. Okay, so now you see here, I am again repeating. Okay, the maximum load on the lug support is the compressive force on the downwind side. If you see the picture again, so wind is okay. So this is a downwind. Downwind side. So the compressive in nature and the support and the weight of the vessel is also compressive. So this side supports is under the maximum compressive stress. So here the maximum the stresses on the downwind side are the determining factor for designing the support. So it is given that therefore the maximum total, the highest, the maximum total compressive load in the most remote support is 4 of PW H minus F N of dB plus summation of W by N. Now, if we write down the meaning, total force due to wind, total force due to wind load acting on the vessel, acting on the vessel. H is the height of the vessel above foundation. Height of the vessel above foundation. F is the vessel clearance from foundation to bottom vessel. So if I show this in diagram, you see here, so this is the foundation. Foundation to up to the top of the vessel is the capital H, and this F, it is the clearance from the foundation to the bottom edge of the vessel. So this is the F. This is the age. Okay. Now, what is dB? Next, dB is the diameter of the anchor bolt circle. Okay. So, this is the dB is the diameter of the anchor bolt circle. N equal to number of the legs and summation of W equal to the total weight of attachment and content. So dB diameter of anchor bolt circle. N equal to number of legs, lugs or bracket, whatever you say. Summation of W equal to total weight. Now, if there is no wind force, if the vessel is installed in a closed or indoor area, so for indoor area where there is no wind force, where indoor or if wind load is neglected, then it becomes only the second term W by N. If there is no wind, fine. Now, three types of bracket are generally used. One, it consists of two vertical gusset plate, two vertical gusset plate with two additional horizontal plate stiffener. Stiffeners. Number two is the two gusset plate but instead of stiffener plate, circumferential stiffening ring are provided. at the top and bottom of bracket. And number 3 is the only vertical gusset plate are welded to the cell. So among these we will discuss the first type bracket, two vertical gusset plate with two additional horizontal plate. Okay, so you see here, or the stiffening rings is there instead of the stiffener plate. So this is the stiffening plate. So there are the stiffener ring. Okay, at the bottom a ring is there. A circular ring is welded with the shell. Now for the first case, for the two vertical gusset plate with two additional horizontal plate stiffener, what happens? Okay, case 1. The axial bending stress in a vessel wall or in the vessel wall due to reaction on the lug so the bending stress is given. Write down important formula. Okay, where beta equal to fourth root of 3 of 1 minus mu square divided by r square into t square. Write down T equal to cell thickness, R equal to mean radius of the cell, P is nothing but the compressive load, H equal to gusset height, B equal to lever arm or load P from bold circle. A is width of the compression plate. Width of compression plate. If we see, let's see, is this there? Okay. So you see here, that is the gasset plate. Is one, two gasset plate and two horizontal stiffener. There is a hole and a short column is attached with this. And these are the dimension I wrote here. That is the B. Okay. That is the H. H is the gasset height. T or T2 is the thickness of the gasset plate. Okay. So the compressive load P induced induces a reaction in the cell around the bracket around the bracket the bending moment is beta square T square P B R square divided by 12 1 minus mu square into AH. Now the last part is the thickness of the gasset plate and the horizontal plate. How to find the thickness of horizontal and gasset plate. So you see in the figure, okay, what I have shown here, if you follow this figure, this one. So I will write the notation according to this notation. So our task is to find the thickness of the gasset plate, okay, and the horizontal plate T1 and T2. So average pressure that is the P average on the base or horizontal plate, or you can say it a stiffener plate. Okay, stiffener भी कह सकते हो, stiffener plate. Okay, so that is the P average equal to the load divided by A into B. Okay, so you see what is the A? A is nothing but the distance between the two cassette plates. Okay, and what is B? B is nothing but the width of the horizontal plate. So that is A and this is B. So the average pressure on this plate is nothing but A P into A by P by A into B. Now the maximum stress in a rectangular plate subjected to a average pressure and fixed at the edges is we take okay we take value of maximum stress 0.5 into P average B square by T1 into A to the power 4 by B to the power 4 plus A to the power 4. So this value will be given. Okay, just a minute. Now, since this load, okay, is distributive, so depending on the smoothness of the surface, 40% extra of F is considered. So in that case, 40% extra means it will be 0.7 P average T square by T1 into A to the power 4 by B to the power 4 plus A to the power 4. And what is the compressive force on gusset plate? For gusset plate, compressive force here also, because the gusset plate will be in compression. So that is the 3 PC by, while you are estimating the T2, A square into 1 upon cos theta. Okay, and this must be less than the allowable stress. Now what is cos theta? What is the theta? Theta is, you see, this is the angle with the horizontal. So this is the acting compressive stress on the gusset plate. So these are the designed for the bracket or leg support. Next day, I will finish to small design of the leg support and as saddle support for the horizontal हिस्से. ठीक है. So tomorrow I will use the leg, a very small few formulas are there, and the leg support.